Okay, so concept one is not, it's sort of an introduction into trig. We're going to review the Pythagorean theorem. We're going to do special right triangles and stuff like that. So this concept is actually, the Pythagorean theorem, special right triangles, and trig ratios. So there's 3 things we're going to be doing in this concept alone. Okay, so our objective, though, is I can understand and use, I'm going to abbreviate, trig relationships, because trigonometric is a really long word, of acute angles. And I'm going to draw the symbol for angles. Okay? I can understand and use trig relationships of acute angles. Acute angles are angles that are less than 90 degrees, for those of you who haven't had geometry in a while. Obtuse angles are larger than 90 degrees, and a right angle is 90 degrees. Okay, so this whole unit is going to be dealing with right triangles. Right triangles have a 90-degree angle. Okay, so let's review the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. Probably the most famous theorem ever. Okay, so these are the 2 legs of the right triangle. Leg, 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 leg. And C is this guy right here. Does anybody know what this is called? It's got a special name. This is the hypotenuse. Hypotenuse. Okay? Hypotenuse is opposite of the right angle, and it's the longest side on the right triangle. Okay, so here's my right triangle here. Here's the right angle. You know it's a right angle because they draw a box. Okay, universal symbol for right angle. Leg, leg, and then the long slanty side across from the right angle is called the hypotenuse. Yes, slanty side is the mathematically correct term. Okay, so that's why you draw an arrow. The right angle is pointing towards the hypotenuse, in case you can't remember. So it's always opposite of the right angle. Okay, anyway, let's do some Pythagorean theorem stuff. So, find the missing side. Give your answer in simplest radical form. So, we're just gonna approximate using a calculator. Okay. Speaking of which, I need to find a calculator. Give me 1 second. Okay, I got my calculator, so we're all good to go. All right, let's do this. So, find the missing side using the Pythagorean theorem. A, B, C, because C is the hypotenuse, so let's set it up. We've got 4 squared plus 8 squared equals x squared. Excuse me. Okay, so 4 squared is 16 plus 8 squared is 64 x squared. 16 and 64 make 80. And how do we get rid of a square? We take the square root. So x equals approximately, hopefully you're using pencil, x is approximately, let's do this, square root of 80, 8.94. Okay, we're just going to do approximating. It's okay, you don't have to do simplest radical form. We're going to approximate. Okay, so that wasn't so hard, was it? All right, let's do the next one. This time, our hypotenuse is 24, so 24 squared is our c squared. Doesn't matter what order you put these 2 in because you're adding them together anyway. So we'll do x squared plus 22 squared equals 24 squared. Okay, so we have x squared plus, 22 squared is 484 equals 24 squared, which is 576. So we need to subtract 484 from 576, 92. Okay, then we take the square root. We get x is approximately, 92, 9.59. All right, and that's how you use the Pythagorean theorem to find a missing side. If you have any questions about this, ask me in class and I can go over these examples again, but it's time to move on for another video.